For decades, we've been asking the wrong question. When we search for other worlds, we ask if they are comfortable, if they are calm, if they look familiar. We look for planets that resemble Earth. Similar size, similar distance from their star, similar temperatures, and when we find worlds that don't fit that image, we discard them. Too hot, too cold, too chaotic. Doch unstable. We assume they are temporary, short-lived, on their way to failure. But this planet forces us to reconsider that assumption, because it survived everything we thought would destroy it. It didn't stabilize. It didn't cool down. It didn't return to balance. It endured, and that changes what viable really means. If a planet can survive extreme heat, loss of atmospheric balance, and rotational chaos for billions of years, then stability may not be the requirement we thought it was. This planet shows that survival doesn't always come from comfort. Sometimes it comes from resistance, from adapting to stress instead of avoiding it. Which means that many of the worlds we've ignored may not be failed planets at all. They may be survivors we don't yet know how to recognize. This is why this planet matters beyond its own system. It challenges the criteria we use to decide which worlds are worth studying and which ones we dismiss too quickly. Because if endurance matters more than balance, then the universe may be filled with worlds that don't look habitable, but persist anyway. And that forces a final question. What if the most important planets I ever discover are the ones we've already decided to ignore? The way we search for other worlds feels logical. We define a narrow set of conditions. A specific temperature range, a stable orbit, a predictable atmosphere, and then we look for planets that fit inside those limits. Anything outside them is labeled unstable, temporary, uninteresting. This approach makes sense on paper. It's efficient. It's measurable, and it's based on what worked here. But that's also the problem. We built our entire search strategy around a single example. Earth. Every model of habitability begins with the assumption that balance is the goal, that planets must settle into calm, regulated states to last. So when we observe worlds that are hot, chaotic, or extreme, we assume they are failing. We classify them as transitional, as objects caught in a brief phase before collapse, and then we move on. But this planet shows how misleading that assumption can be. Because it exists in a state we would normally classify as unstable, yet it has persisted for billions of years. That forces an uncomfortable realization that are most resilient. They describe how planets prefer to behave, not how they must behave. In practice, many planetary systems don't move smoothly toward equilibrium. They destabilize. They get trapped in extreme states. Some of those states are short-lived, others aren't. And from a distance, it's difficult to tell the difference. So we label them all the same: unstable, unviable, uninteresting. This is the blind spot. We've been searching for planets that look peaceful now, instead of planets that have proven they can endure stress. We look for comfort, but the universe may reward resistance. And that mismatch affects everything. It shapes where we point our telescopes. It determines which signals we analyze further. It decides which discoveries get attention, and which ones are quietly ignored. This planet wasn't missed because it was hidden. It was missed because it didn't fit the story we expected to find. And that raises a deeper concern. If our search methods are biased toward calm worlds, how many enduring worlds have we already overlooked? How many planets exist in extreme states, surviving in ways we don't yet recognize as meaningful? To unswear that, We have to stop asking which planets look habitable today, and start asking which planets have learned how to last. What this planet teaches us is not how to find comfort. It teaches us how to recognize endurance. For a long time, we assumed that lasting worlds must be balanced worlds. That stability was the natural endpoint of planetary evolution. That extremes were temporary mistakes. But this planet shows a different outcome. It didn't settle into balance, it settled into persistence. The forces that shaped it never disappeared. They stacked. They reinforced each other, and instead of collapsing the system, they locked it in place. That means longevity doesn't always come from calm conditions. Sometimes it comes from a system's ability to absorb stress without breaking. This reframes how we should think about planets across the universe. A world doesn't need to be gentle to be long. It needs to be resilient. Resilience looks different from stability. It leaves scars. It creates asymmetry. It produces environments that seem hostile at first glance. But those environments can last. And if they can last, they matter. Because time is the real filter. Any planet can look promising for a moment. Only a few can endure for billions of years. This planet endured not by avoiding extremes, but by adapting to them faster than they accumulated. That insight changes how we interpret what we see. When astronomers detect a planet with extreme heat, a strange rotation, or an atmosphere that doesn't behave as expected, we shouldn't assume failure. We should ask a different question. How long has it been like this? Because if a world has survived an extreme state for millions or billions of years, then that state is not temporary. It is its equilibrium. And that means the universe may be filled with worlds that don't look habitable, don't look stable, and don't look familiar, but persist anyway. Worlds that our current models struggle to categorize. Worlds that sit outside our definitions, not outside physics. This planet didn't just expose a blind spot in planetary science. It exposed a bias. We search for places that look like home. But the universe may be dominated by places that learned how to survive without one. And that realization shifts the goal entirely. The most important planets may not be the ones where life looks easy. They may be the ones where survival proved possible against expectation. Which means our greatest discoveries may not come from worlds that resemble Earth, but from worlds that endured conditions Earth never could. In the next video, we'll explore what these resilient worlds could mean for life itself, and why the most extreme planets might tell us more about the universe than the comfortable ones ever will.